Hello, in this lecture we will find the area of the green shape. In the drawing we have triangle ABC. We know that the angle BAC of triangle ABC, this angle equals to 60 degrees. And we also know that BF line segment BF equals to DF equals to CF or FC, that equals to DF, that equals to EF. So all those four line segments are equal to each other. And we also know that the area of triangle BDF is equal to 8 square units. The area of this triangle is equal to 8 square units. And the area of triangle FEC, this triangle, is equal to 15 square units. And we want to find out the area of quadrilateral ADFE, the area of this ring shape that is actually quadrilateral. So first of all, we will define angle ABC of triangle ABC as B, and we will define angle ACB, this angle, as C. And we have a rule that states that the sum of the angles in any triangle is equal to 180 degrees, and especially the sum of the angles in triangle ABC, the big triangle, is equal to 180 degrees. That is to say, angle BAC that equals to 60 degrees plus angle B, this angle, plus angle C must be equal to 180 degrees. Okay, so we have equation number 1 that says that the sum of the angles in the big triangle ABC equals to 180 degrees. Here we will subtract 60 degrees from equation number 1, and we will get that B plus C equals to 180 degrees minus 60 degrees is 120 degrees. Okay? B plus C equals to 120 degrees. Okay? Actually, we have a rule, I will call it rule 1 or rule number 1. Rule number 1 states that in front of equal sides in the triangle there are equal angles. In front of equal sides in the triangle there are equal angles. So actually, if we have triangle ABC, and we know that side AB of triangle ABC equals to side AC, AB equals to AC, then in front of side AB of triangle ABC we have angle ACB, and those two sides are equal to each other, and in front of side AC of triangle ABC we have angle ABC. So according to rule number 1, those two angles that are located in front of equal sides in triangle ABC are equal to each other. So angle ACB equals to angle ABC. Okay, those two angles are equal to each other. So actually, if we look at the triangle DBF, this triangle DBF, we know that side BF of triangle DBF equals to side DF. Okay, so side BF of triangle BDF equals to side DF. So according to rule number 1, in front of side DF we have angle B. So in front of side BF we have angle BDF. So actually those two angles that are located in front of equal sides of triangle BDF must be also equal to each other. So if this angle is B, then this angle also must be equal to B. Okay, and then we will focus on triangle FEC. So in triangle FEC, we know that FC equals to EF. Those two sides are equal to each other, and in front of FE we have angle C. So in front of FC we have angle FEC. So those two angles are located in front of equal sides, therefore they must be equal to each other. Therefore, if this angle is C, this angle must be also equal to C. Okay, so in the next step we will define angle DFB. This angle SP, angle DFB equals to P according to our definition, and angle EFC, this angle will be equal to Q. Okay, and again we have the rule that the sum of the angles in any triangle is equal to 180 degrees. Therefore, in triangle BDF, the sum of the angles is equal to 180 degrees. That is to say, B plus B plus P equals to 180 180 degrees. So 2b plus p equals to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So in triangle BDE, the sum of the angles is equal to 180 degrees. So we will subtract from this equality 2b, and actually it is triangle BDF. This triangle BDF, the sum of the angles is equal to 180 degrees. So here we'll subtract 2b from this equality, and we will get that P equals to 180 degrees minus 2b and we also know that the sum of the angles in triangle FEC is equal to 180 degrees. Again, in triangle FEC, the sum of the angles is equal to 180 degrees. Therefore, C plus Q equals to 180 degrees. Again, in triangle FEC, the sum of the angles is equal to 180 degrees. That is to say, 2C plus Q equals to 180 degrees. Here we will subtract from this equality 2C, and we will get that Q equals to 180 degrees minus 2C, and we also found out that P equals to 180 degrees minus 2B. Here we will add Q to P, so Q plus P will be equal to 180 degrees plus 180 degrees is actually 360 degrees. Minus 2C plus minus 2B is minus 2C minus 2B. So here we will take minus 2 as a common factor of this expression, and we will get that Q plus P equals to 360 degrees minus 2 times B plus C. Okay. Question number 2 states that Q plus P equals to 360 degrees minus 2 times B plus C. But we have already found out in question number 1 that B plus C equals to 120 degrees. So we actually can substitute B plus C in equation number 2 by 120 degrees, because B plus C equals to 120 degrees. Okay, so Q plus P equals to 360 degrees minus 2 times, and instead of B plus C we write down 120 degrees. So in total we got that Q plus P equals to 360 degrees minus 2 times 120 degrees. That is actually equals to 240 degrees. So Q plus P equals to 360 degrees minus 240 degrees Q plus P equals to 360 degrees minus 240 degrees is 120 degrees. So we actually found out that Q plus P equals to 120 degrees, and we have already found out that B plus C equals also to 120 degrees. So actually we have those two equations. Equation number 1 states that B plus C equals to 120 degrees, and equation number 2 states that Q plus P also equals to 120 degrees. Okay, so in the next step we will find out the size of angle EFD. We will find out the size of this angle EFD, according to rule number 2 that states that the sum of the angles on a straight line is equal to 180 degrees. So I will read rule number 2 again. Rule number 2 states that the sum of the angles on a straight line is equal to 180 degrees. Okay? So actually BC is one of the triangles ABC sides. Therefore BC is a straight line. Okay, BC is a straight line. Therefore, according to rule number 2, the sum of the angles at any point on the straight line BC must be equal to 180 degrees. So if we focus at point F that is on the straight line BC, the sum of the angles of point F of the straight line BC must be equal to 180 degrees. That is to say, P plus Q plus angle DFE must be equal to 180 degrees according to rule number 2. Okay, P plus Q plus the size of angle DFE must be equal to 180 degrees according to rule number 2. But we have already found out in question number 2 that P plus Q equals to 120 degrees. So we can substitute P plus Q in this equality by 120 degrees. So we get that 120 degrees plus angle DFE equals to 180 degrees. So here we will subtract 120 degrees from this equality, and we will get that the size of angle DFE equals to 180 degrees minus 120 degrees is 60 degrees. So we found out that the size of the missing angle is actually 60 degrees. So the size of this angle DFE equals to 60 degrees. In the next step we will join together points D and E by a straight line. Actually, we created triangle DFE. So in triangle DFE, we know that side BF equals to side EF. It is given us in the question. Again, in triangle DFE, we know that side BF of the triangle is equal to side EF. Therefore, according to rule number 1, that says that instead of equal sides in the triangle, there are equal angles. Therefore, in front of side DE of triangle DFE, we have this angle, and if we define this angle FDE as Y, then we know according to rule number 1 that in front of equal sides of the triangle there are equal angles. So in front of DF we have angle FED, and in front of FE we have angle FDE. So according to rule number 1, those two angles that are located in front of equal sides are also equal to each other. That is to say, this angle is also equal to y. And now we will implement the rule that the sum of the angles in triangle DFE equals to 180 degrees. That is to say, y plus 60 degrees must be equal to 180 degrees. Again, the sum of the angles in the grid triangle DFE must be equal to 180 degrees. Therefore, 2y plus 60 degrees equals to 180 degrees. Here we subtract 60 degrees from this equality, and we will get the 2y equals to 180 degrees minus 60 degrees is 120 degrees. So we found out that 2y equals to 180 degrees. Now we will define this equality by 2 in order to get the value of y. We will find out that y equals to 120 degrees over 2 is 60 degrees. So the size of angle y is 60 degrees. So here we will substitute y by 60 degrees. So angle FDE equals to 60 degrees, and angle DEF also equals to 60 degrees. Okay, so we actually found out that all the angles in triangle FDE equals to 60 degrees, therefore it is an equilateral triangle. That is to say, all of its sides are equal to each other. So actually, side DF equals to side FE equals also to side DE. And if we define, actually, all the line segments that I marked in two red lines are equal to each other. So if VF equals to X, then FC also will be equal to X, and FE also equals to X, DF also equals to X, and DE also equals to X. Okay? So, in the next step, we will find out the angle ADE and angle AED. We'll find out the sizes of those two angles in triangle ADE. Okay, according to the rule that states that the sum of the angles in any triangle, or according to the rule number 2, that states that the sum of the angles in a straight line is equal to 180 degrees. We can write down that angle C plus 60 degrees plus angle AED must be equal to 180 degrees according to rule number 2. Okay, according to rule number 2, angle C plus 60 degrees plus angle AED must be equal to 180 degrees according to rule number 2. So here we will subtract 60 degrees and C from this equality, and we will get that angle AED will be equal to 180 degrees minus 60 degrees is 120 degrees minus C. Okay, angle AED equals to 120 degrees minus C. But we have already found out in equation number 1 that B plus C equals to 120 degrees. So here we will subtract C from this equation number 1, and we will get that B equals to 120 degrees minus C. Okay, so here 120 degrees minus C according to equation number 1 equals to B. So actually from this equality we can derive that angle AED equals to B. Okay, from this equality we can derive that angle AED equals to B. Angle AED equals to B. Okay, angle AED, this angle equals to B. And we will do the same process on the other side of triangle ABC. If we focus at point D, according to rule number 2, the sum of the angles on a straight line is equal to 180 degrees. So at point D, we know that the sum of the angles on the straight line AB equals to 180 degrees. That is to say, angle B plus 60 degrees plus angle ADE must be equal to 180 degrees according to rule number 2. Okay. Again, on the straight line AB at point D, we know that the sum of the angles is 180 degrees. That is to say, angle B plus 60 degrees plus the size of angle ADE must be equal to 180 degrees according to rule number 2. So here we'll subtract B and also 60 degrees from this equality, and we will get that angle ADE equals to 180 degrees minus 60 degrees is 120 degrees minus B. Okay? But we have already found out that, according to question number 1, that B plus C equals to 120 degrees. So we will subtract minus B from equation number 1, and we will get that C equals to 120 degrees minus B. Okay, so C equal to 150 degrees minus B, but we have here 120 degrees minus B. According to equation number 1, it equals to C. And again, from this equality, we can derive that angle ADE equals to C. Okay, angle ADE equals to C. So actually, angle ADE, this angle equals to C. Okay. In the next step, we will focus on the great triangle, triangle ADE, and on the big triangle, triangle ABC. We will prove that those two triangles are similar to each other. So in triangles ABC, in triangle in ADE, okay, so we'll focus on triangle ADE and on the big triangle, triangle ABC, okay? We'll focus on those two triangles, on the small triangle, triangle ABC, and on the big triangle, on the small triangle, triangle ADE, and on the big triangle, triangle ABC. So actually, angle AED on triangle ADE, angle AED equals to angle ABC of triangle ABC and both those two angles are equal to beta. Okay. So again, angle AED equals to angle ABC, and both those two angles are equal to beta to B. Okay. And also we know that angle ADE of the small triangle ADE angle ADE. This angle equals to angle ACB. This angle and both those two angles are equal to C. Okay. So again, angle ADE equals to angle ACB, and both those two angles are equal to C. And then the third angle, this angle is a common angle. It belongs both to the small triangle, triangle ADE, and it also belongs to the big triangle, triangle ABC. Okay, so you can write down that angle A equals to angle A it is actually a common angle. Angle A equals to angle A. It is a common angle. And then angle A equals to angle A. It is a common angle. Actually, this angle A equals to 60 degrees, and it belongs both to the small triangle, triangle ADE, and it also belongs to the big triangle, triangle ABC. Okay? So, we actually proved that all the three angles of the small triangle, triangle AD are congruent to all the three angles of triangle ABC. Therefore, we proved that triangle ABC is similar to triangle ADE. Okay, ADE. So triangle ABC is similar to triangle ADE according to angle similarity rule. So actually, angle similarity rule states that if you prove that all the angles of one triangle are congruent to all the angles of another triangle, then you proved that those two triangles similar to each other according to angle similarity rule. Okay? In the next step we have rule number 3 that relates to similar triangles. According to rule number 3, the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. So I'll read all number 3 again. All number 3 states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. Okay, so actually if we have we will implement rule number 3 in our two similar triangles. According to rule number 3, the area of triangle ABC that is the sign of area. So the area of triangle ABC over the area of triangle ADE, that is actually the ratio between the areas of those two triangles, is equal to the square ratio of the corresponding sides. And the square ratio of the corresponding sides is actually BC square over DE square. Again, the ratio between the areas of those two similar triangles, that is to say the area of triangle ABC over the area of triangle ADE, equals to the square ratio of the corresponding sides. That is to say it equals to BC square over DE square. Okay, but what is the side of side BC of triangle ABC? It actually equals to x plus x. So BC equals to 2x and BC square is 2x square. 2x square over DE. What is the size of DE? DE equals to x. So DE square is x square. So actually we got 2x square over x square. 2x square equals to 4x square, and 4x square over x square is 4. So we found out that the area of triangle ABC over the area of triangle ADE equals to 4. So here we will multiply this equality by the area of triangle ADE, and we will get that the area of triangle ABC equals to 4 times the area of triangle ADE. again the area of triangle ABC equals 4 times the area of triangle ADE. Okay, the area of triangle ABC equals 4 times the area of triangle ADE, or the area of triangle ABC is 4 times bigger than the area of triangle ADE. In the next step we will calculate the area of quadrilateral DBCE. So what is the area of quadrilateral DBCE? The area of quadrilateral DBCE actually equals to the area of the big triangle ABC minus the area of the small triangle ADE. Again, the area of triangle ABC minus the area of the small triangle ADE will be equal to the area of quadrilateral DBCE. Okay, so we write it down. Okay, again, the area of quadrilateral DBCE equals to the area of the big triangle ABC minus the area of the small triangle ADE. But we have already found out that the area of triangle ABC equals to 4 times the area of triangle ADE. So we can substitute the area of triangle ABC by 4 times the area of triangle ADE. So we'll do it now and we will get that the area of quadrilateral DBCE equals to 4 times the area of triangle ADE, because the area of triangle ABC equals to 4 times the area of triangle ADE, so we substituted the area of triangle ABC by 4 times the area of triangle ADE minus 1 times the area of triangle ADE. So the area of quadrilateral DBCE equals 3 times the area of triangle ADE minus 1 time the area of triangle ADE will be equal to 3 times the area of triangle ADE. Again, the area of quadrilateral DBCE equals to 3 times the area of the small triangle ADE. And we have already found out that the area of triangle ABC equals to 4 times the area of triangle ADE. Okay. So, in the next step I will present to you a new formula for the area of any triangle. So actually, if we have triangle ABC and we know that the size of side AB of triangle ABC is A, and we also know that the size of side AC of triangle ABC is B, and we know also that the angle between side AB of triangle ABC and side AC is theta. Then the area of this triangle ABC, the area of triangle ABC will be equal to A times B times sine theta over 2. Again, the area of this triangle we can actually calculate by this formula the area of any triangle, because ABC can be any triangle. So the area of this triangle ABC equals to A times B times sine theta over 2. Okay, so we will implement this rule, or we'll use this formula for the area of a triangle in order to find out the areas of triangle FEC and the areas of triangle DBF. Okay, actually if we divide the area of triangle EFC by the area that is 15 square units by the area of triangle DBF, this triangle that is 8 square units, we will get 15 over 8. And in the other side of the equality, we will use the formula for the area of the triangle, the new formula for the area of the triangle, in order to calculate the area of the big triangle, triangle FEC. So according to the new formula that I presented to you, the area of triangle FEC, we know that the area is 15 square units, but we want to find out the formula for that area. So the area of triangle FEC, according to the formula that I presented to you, will be equal to FE times FC times sine theta over 2. Okay? FE times FC times sine Q. The angle between FE and FC is Q over 2. Again, the area of triangle FEC, according to the formula that I presented to you, will be equal to FE times FC times sine Q over 2. And the area of the small triangle DBF, will be equal to DF times BF times sine P over 2. Okay, again, the area of the small triangle DBF, according to the formula that I presented to you, will be equal to BF times BF times sine P over 2. Okay, so 15 over 8 equals to, what is the size of EF? EF equals to X. and CF also equals to x. So EF times CF is x squared times sine Q over 2, all divided by DF. What is the size of DF? DF equals to x. And what is the size of BF? BF also equals to x. So DF times BF is x times x, that is x squared, times sine P over 2. So we got this equality. Here we will move 2 to the numerator and x squared times sine P to the denominator, and we will get that x squared 2x squared times sine Q equals to 2x squared times sine P, all equals to 15 over 8. So we got this equality. Here we have 2x squared over 2x squared is 1, so 2x squared is cancelled. So in total we got that sine Q over sine P equals to 15 over 8. Okay? We found out that sine Q over sine P equals to 15 over 8. But we have already found out that Q plus P equals to 120 degrees according to equation number 2. We know that Q plus P equals to 120 degrees. Here we will subtract P from this equality and we will get that Q equals to 120 degrees minus P. Okay? The value of Q is 120 degrees minus P. So we actually can substitute Q in this equality by 120 degrees minus P. So we will do it now, and we will get that sine Q, and instead of Q we will write down sine 120 degrees minus P over sine P equals to 15 over 8. So sine 120 degrees minus P, we will find out the value of sine 100 degrees minus P according to a new trigonometric identity that states that sine A minus B sine A minus B equals to sine A cosine B minus sine B cosine A. Okay, so we will find out the value of sine 120 degrees minus p according to this trigonometric identity. So the value of sine 120 degrees minus p according to this trigonometric identity will be equal to sine 120 degrees minus p will be equal to sine 120 degrees times cosine p minus sine p times cosine 120 degrees. Okay, so actually sine 120 degrees minus p equals to sine 120 degrees is root 3 over 2 times cosine p minus cosine 120 degrees is minus 1 over 2, so and minus times minus is plus. Here we have cosine p. Sine, what is left here is sine p. So here minus times minus is plus, so sine 120 degrees minus p equals to root 3 over 2 times cosine p plus 1 over 2 times sine p. Okay, so here we will substitute sine 120 degrees minus p by this expression that equals to sine 120 degrees minus p, and the original expression is sine 120 degrees minus p over sine p equals to 15 over 8. Okay, again we will substitute sine 120 degrees minus p by this expression that equals to sine 120 degrees minus p, and we will get that root 3 over 2 times cosine p here we divide all by sine p, so it is over sine p minus plus 1 over 2 times sine p over sine p is 1 equals to 15 over 8. So again we substituted sine 120 degrees minus p by this expression that equals to sine 120 degrees minus p in this equality, and we found out that root 3 over 2 cosine p over sine p plus 1 over 2 sine p over sine p equals to 15 over 8. So sine p over sine p is 1, and cosine p over sine p is cotangent p. So we get that root 3 over 2 times cotangent p plus 1 over 2 equals to 15 over 8. Okay, now cotangent p, we have the trigonometric identity that states that cotangent p equals to 1 over tangent p, so we will substitute cotangent p in this equality by 1 over tangent p, and we will get that root 3 over 2 times tangent p plus 1 over 2. 1 over 2 is 4 over 8 plus 4 over 8 equals to 15 over 8. So here we will subtract 4 over 8 from this equality, and we will get that root 3 over 2 times tangent p equals to 15 over 8 minus 4 over 8 is actually 11 over 8. So here we will multiply this equality by tangent p, and we will get that 8 over 11 times tangent p equals to root 3 over 2. Okay, so we found out that 11 over 8 times tangent p equals to root 3 over 2. Here we will multiply this equality by 11, and then we will divide it by 8 in order to get the value of tangent p. We will get that tangent p equals to root 3 over 2 times 11 over 8. Okay. So actually here is actually 11 over 8. 11 over 8 tangent p equals to root 3 over 2. Okay, so here we multiplied this equality by 8, and then we divided it by 11. So in total we got that tangent p equals to root 3 over 2 times 8 over 11. Okay, so here 8 over 2 is 4, so I write it down. We will get that tangent p equals to 4 times root 3 over 11. So we found out that tangent p equals to 4 times root 3 over 11. But the function tangents is actually expresses the relationship in a right triangle, the relationship between the sides of a right triangle. So actually this specific equality, we can express it, we can draw this specific equality actually in this right triangle. We have angle P. Actually this right triangle with its sizes expresses exactly this function, because here in this drawing the value of tangent P in this right triangle will be equal to 4 times root 3 over 11. Okay, so this drawing expresses the fact that tangent P equals to 4 times root 3 over 11, exactly the same result as we found here. So we will find out the hypotenuse of this right triangle. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, 4 times root 3 squared plus 11 squared equals to the square of the hypotenuse. But we want the hypotenuse itself and not the square of the hypotenuse. This expression is actually the square of the hypotenuse. And if we want the hypotenuse itself, we must take a root of this square of this expression in order to get the hypotenuse itself. So the size of the hypotenuse will be equal to the root of 4 times root 3 square plus 11 square. Okay, and here the value of sinus P will be equal to, sinus P equals to the side that is in front of angle P, that is 4 times root 3 over the hypotenuse, that is actually 4 times root 3 square is 48, plus 11 square is 121. 48 plus 121 is 169, and the root of 169 is 13. So we found out that sinus P equals to 4 times root 3 over 13. Again, the value of sinus P is 4 times root 3 over 13. Okay, so in the next step we'll calculate the area of the small triangle DVF according to the formula that I gave to you. So actually the area of this triangle according to the formula that I gave to you, that I presented to you, is actually equals to df times bf is, df is x and bf is also x, so df times bf is x times x, that is actually x squared, times sinus P over 2. So that is actually the formula for the area of this triangle, and we already know that the area of this triangle equals to 8 square units. It is given us in the question. Okay, so actually we have the formula for the area of triangle DBF, the small triangle. That is the formula, and we know that the area of the small triangle DBF equals to 8 square units, and we have already found out that sinus P equals to 4 times root 3 over 13, so we can substitute sine P in this equality by the value of sine P, that is 4 times root 3 over 13, and we will find out that x squared over 2 times sine P, that is actually 4 times root 3 over 13, equals to 8. Okay, we substituted sine P in this equality by the value of sine P. So here, so we got this equality. Here 4 over 2 is 2. So I write it down. In total we will get that 2 times root 3 over 13 times x squared equals to 8. Okay, 2 times root 3 over 14 times x squared equals to 8. Here we will divide this equality by 2, and we will get that root 3 over 13 times x squared equals to 4. Okay, we found out that root 3 over 13 times x squared equals to 4. Here we will multiply this equality by 13, and then we will divide it by root 3 in order to get the value of x squared. So we will get that x squared equals to 13 times 4 is 52 over root 3. So we found out that x squared equals to 52 over root 3. In the next step we will find out the area of the equilateral triangle DEF. So the area of the equilateral triangle DEF, according to the formula that I presented to you, will be equal to x times x, that is x squared, times sine 60 degrees. Sine 60 degrees is root 3 over 2, all divided by 2. Okay, again, the area of the equilateral triangle DEF equals to x squared times root 3 times 2 is 4, so I write it down. So the area of triangle DEF, the equilateral triangle DEF, equals to x squared times root 3 over 4. But we have already found out that x squared equals to 52 over root 3, so we'll substitute x squared in this equality by 52 over root 3, and we will find out that the area of the equilateral triangle DEF equals to x squared is 52 over root 3 times root 3 over 4. So here we have root 3 over root 3 is 1, so root 3 is cancelled, and 52 over 4 is 13. So we found out that the area of the equilateral triangle DEF is equal to 13 square units. Okay, the area of the equilateral triangle equals to 13 square units. So we actually can calculate the area of quadrilateral BDEC. The area of quadrilateral BDEC equals to the area of the small triangle, that is 8 square units, plus the area of quadrilateral BDEF that we already found out, that is 13 square units, plus the area of triangle EFC, that is 15 square units. Okay, so the area of quadrilateral BDEF equals to 8 plus 13 is 21, 21 plus 15 is 36. So the area of quadrilateral BDEF equals to 36 square units. But we have already found out that the area of quadrilateral BDEC, the area of quadrilateral BDEC equals to 3 times the area of triangle AED. Okay? And we also know that the area of quadrilateral BDEC equals to 36 square units. So actually, from this equality, we can derive that the 3 times the area of triangle AED equals to 36 square units. Okay? 3 times the area of triangle AED equals to 36 square units. Here we will divide this equality by 3, and we will get that the area of triangle AED equals to 12 square units. So the area of the green triangle AED is 12 square units, and the area of the green shape ADEF, it is actually quadrilateral ADEF, will be equal to the area of triangle ADE, that is 12 square units, plus the area of the equilateral triangle DEF, that is 13 square units, or the area of equilateral ADEF equals to 12 plus 13, that is 25 square units. Okay, so we found out that the area of the green shape, or the area of quadrilateral ADEF, equals to 25 square units. Again, the area of this green shape, or the area of quadrilateral ADEF, the green shape, equals to 25 square units. Okay, now I'll summarize the lecture. Actually, we wanted to find out the area of the green shape ADEF, and we know that the angle BAC of triangle ABC equals to 60 degrees, and we also know that PF equals to CF equals to DF equals to EF. Okay. we also know that the area of this triangle DBF is 8 square units, and the area of the big triangle EFD equals to 15 square units. And we want to find out the area of the green shape, or the area of quadrilateral ADFE. Okay? First of all, we will use the rule that states that the sum of the angles in any triangle is equal to 180 degrees, and especially the sum of the angles in the big triangle ABC equals to 180 degrees. Therefore, this angle that is 60 degrees plus angle B plus angle C must be equal to 180 degrees. So 60 degrees plus B plus C equals to 180 degrees, and if we subtract 60 degrees from the equality, we will get that B plus C equals to 120 degrees. So equation number 1 states that B plus C equals to 120 degrees. And then we have rule number 1 that states that in front of equal sides in the triangles there are equal angles. So if in triangle ABC side AB equals to side AC, then those two angles must be also equal to each other because they are located in front of equal sides. So according to rule number 1, angle ACB equals to angle ABC because those two angles are located in front of equal sides in the triangle. So that is rule number 1. So in this triangle DBF, we know that BF equals to DF, and in front of DF we have angle B, and in front of BF we have angle DBF. So those two angles that are located in front of equal sides in the triangle must be equal to each other, and if this angle is B, this angle must be also equal to B. Okay? And then we focused on triangle FEC, the big triangle. We know that in this triangle, side FC equals to side EF, and side EF is located in front of angle C, while side FC is located in front of angle FEC. So those two angles that are located in front of equal sides in the triangle must be equal to each other. So if this angle is C, then this angle must be also equal to C. Okay? Then we defined angle DFB as P and angle EFC as Q, and again we use the rule that states that the sum of the angles in any triangle is equals to 180 degrees. That is to say B plus B plus P in triangle DBF equals to 120 degrees, or in other words, in triangle DBF, 2B plus B equals to 180 degrees. We subtracted 2B from this equality, and we got that angle P equals to 180 degrees minus 2B. Then we focused on triangle EFC, and again the sum of the angles in triangle EFC equals to 180 degrees. That is to say C plus Q equals to 180 degrees, or in other words, 2c plus q equals to 180 degrees in triangle EFC. We subtracted 2c from this equality and we got that q equals to 180 degrees minus p. And we have already found out that p equals to 120 degrees minus p. 180 degrees minus 2b. So we added q to p. So q plus p equals to 180 degrees plus 180 degrees is 360 degrees minus 2b plus minus 2c plus minus 2b equals to 2c plus minus 2b. Okay, then we took out the common factor of minus 3 from this expression and we found out that q plus p equals to 360 degrees minus 2 times b plus c, but we have already found out in equation number 1 that b plus c equals to 120 degrees, so we can substitute b plus c by 120 degrees. After we substituted b plus c by 120 degrees, we found out that q plus p equals to 120 degrees. Q plus p equals to 120 degrees. That is equation number 2. And equation number 1 states that p plus c also equals to 120 degrees. And then we have rule number 2 that states that the sum of the angles on a straight line is equal to 180 degrees. Okay, we used rule number 2 in order to find out the size of angle DFE, this angle. We know that BC is one of ABC's sides, or BC is the side of triangle ABC, therefore it is a straight line, and according to rule number 2, the sum of the angles on a straight line is equal to 180 degrees. So if you focus on point P on the straight line BC, the sum of the angles must be equal to 180 degrees. That is to say, Q plus P plus the size of this angle, angle DFE, must be equal to 180 degrees according to rule number 2. Again, according to rule number 2, P plus Q plus the size of angle DFE must be equal to 180 degrees, okay, in triangle DFE. So here we know that P plus Q equals to 120 degrees according to equation number 2. So we can substitute P plus Q by 120 degrees. Okay, we substituted P plus Q by 120 degrees and we found that the size of angle DFE equals to 60 degrees. So this angle DFE equals to 60 degrees in its size. Then we connected together points D and E by a straight line. So in triangle DFE, the triangle DFE, the green triangle DFE, we know that side DE equals to side DF. Those two sides are equal to each other. DF equals to BDE. And according to rule number 1, in front of equal sides, there are equal angles. Again, in triangle DFE, BF equals to EF. And according to rule number 1, in front of equal sides, there are equal angles. So those two angles that are located in front of equal sides must be also equal to each other. So if this angle is y, then this angle must be equal also to y. And we know that the sum of the angles in any triangle is equal to 180 degrees. Therefore, the sum of the angles in triangle DFE equals to 180 degrees. That is to say, 2y plus 60 degrees must be equal to 180 degrees. We subtracted 60 degrees from this equality and we found out that 2y equals to 120 degrees. Then we divided this equality by 2 and we found out that y equals to 60 degrees. So this angle equals to 60 degrees and this angle also equals to 60 degrees. So actually all the angles in triangle DFE equals to 60 degrees, therefore triangle DFE is an equilateral triangle. And in an equilateral triangle, all the sides are equal to each other. So if this side is x, then this side is also x and this side is also x, and all the sides that I marked in two red lines are also equal to each other. So this BF also equals to x and FC also equals to x, and all the other sides also that I marked with two straight lines, two red lines, are equal to each other. Okay, so then we found the sizes of those two angles according to rule number 1, that states that the sum of the angles in a straight line is equal to 180 degrees. So actually AC is a straight line because it is the side of triangle ABC. Therefore, if we focus at point E, the sum of the angles on the straight line equals to 120 degrees, that is to say C plus 60 degrees plus angle AED must be equal to 180 degrees according to rule number 2. Again, angle C plus 60 degrees plus angle AD must be equal to 180 degrees. We subtracted C and 60 degrees from this equality and we got that angle AED equals to 120 degrees minus C, and we know that B plus C equals to 120 degrees, so B equals to 120 degrees minus C. So we can write here that 120 degrees minus C equals to B according to equation number 1. From this equality we derived that angle AEB equals to B. So this angle AED equals to B. Then we repeated on the same process on the other side of the triangle. According to rule number 2, the sum of the angles of the straight line AB equals to 180 degrees, and if we focus at point D, the sum of the angles on the straight line AB at point D must be equal to 180 degrees. That is to say B plus C plus angle ADE must be equal to 180 degrees according to rule number 2. Again, B plus 60 degrees plus the size of angle ADE equals to 180 degrees according to rule number 2. We subtracted B and 60 degrees from this equality and we got that angle ADE equals to 120 degrees minus B. But we know that B plus C equals to 120 degrees, so from equation number 1 we got that C equals to 120 degrees minus B, so here 120 degrees minus B equals to C according to equation number 1. So from this equality we can derive that angle ADE equals to C. Again, angle ADE equals to C, so this angle ADE equals to C. Then we proved that triangle ADE, the green triangle, is similar to triangle ABC. Because we have angle AED that equals to angle ABC, those two angles are equal to each other, both of them are equal to alpha, to B, both those two angles are equal to B. Okay, And we also know that angle ADE equals to angle ACB. Those two angles are also equal to each other, and both of them are equal to C. And the third pair of angles, actually this angle is a common angle. It belongs to both triangles, to triangle ADE and also to triangle ABC. So we can write down that angle A equals to angle A. It is a common angle. So we proved that all the angles in the big triangle, triangle ABC, are congruent to all the angles in the small triangle, triangle ADE. So we actually proved that the big triangle, triangle ABC, is similar to the small triangle, triangle ADE, according to angle similarity. And we have rule number 3 that relates to similar triangles. According to rule number 3, the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. Okay? The ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. So actually, if we implement this rule number 3 in our similar triangles, we can create the formula that states that the area of triangle ABC over the area of triangle ADE must be equal to the ratio between the corresponding sides, that is BC square over DE square. But we know that BC equals to x plus x, so BC is 2x. And 2x squared is 4x squared. And DE equals to x, so DE squared is x squared. So in total we have here 4x squared over x squared equals to 4. So the ratio between the area of the big triangle, triangle ABC, to the area of the small triangle, triangle ADE equals to 4. So if we multiply this equality by the area of the small triangle, triangle ADE, we will get that the area of triangle ABC equals 4 times the area of triangle ADE. And then we calculated the size of quadrilateral DBEC. The area of quadrilateral DBEC equals to the area of triangle ABC minus the area of the small triangle, triangle ADE. Okay? Again, the area of quadrilateral DBEC equals to the area of triangle ABC minus the area of the small triangle, triangle ADE. But we have already found out that the area of triangle ABC is 4 times the area of triangle ADE, so we can substitute the area of triangle ABC by 4 times the area of triangle ADE. So at the end we found out that the area of quadrilateral DBEC equals 4 times the area of triangle ADE, and we have already found out that the area of triangle ABC equals 4 times the area of triangle ADE. Okay? Then I presented to you a new formula for the area of any triangle. The area of this triangle, that can be any triangle, is A times B times sine theta over 2. Again, the area of this triangle equals to A times B times sine theta over 2. Okay? We calculated the area of those two triangles according to the new formula. Actually, the area of the big triangle over the area of the small triangle is 15 over 8, because the area of the big triangle is 15 square units and the area of the small triangle is 8 square units. Okay, so the area of the big triangle is 15 square units, but what is the area in terms of the expression for the area? According to the formula that I presented to you, the area of the big triangle, triangle EFD, equals to x times sine q over 2. Okay, it equals to x squared times sine q over 2, and the area of the small triangle is equals to x times sine p over 2, or x squared times sine p over 2. Here 2x squared is cancelled, and we found out that sine q over sine p equals to 15 over 8. But we have already found out in equation number 2 that q plus p equals to 120 degrees. So from equation number 2, we know that q equals to 120 degrees minus p, so we can substitute q in this equality by 120 degrees minus p. We substituted q by 120 degrees minus p, and we got this equality that sine 120 degrees minus p over sine p equals to 15 over 8. Then, in order to find out the value of sine 120 degrees minus p, I presented to you a new trigonometric identity for sine A minus B. Sine A minus B equals to sine A times cosine B minus sine B times cosine A. Okay, we use this trigonometric identity in order to find out the value of sine 120 degrees minus p. And at the end, we found out that the value of sine 120 degrees minus p equals to this expression. So we can substitute sinus 120 degrees minus p by this expression that equals to sine 120 degrees minus p. We substituted sine 120 degrees minus p in this equality by this expression. And after solving this equality, we found out that tangent p equals to 4 times root 3 over 11. Okay, from this equality, we calculated the value of sine p, and we found out that sine p equals to 4 times root 3 over 13. After we found out the value of sine p, we know that the area of triangle DBF equals to x times sine p over 2. And we know that the area equals to x square units. Okay, so the area of the small triangle equals to x squared times sine p over 2. But we have already found out that sine p equals to 4 times root 3 over 3, so we can substitute sine p by 4 times root 3 over 13 in this equality. So after we substituted sine p by 4 times root 3 over 13, we found out that x squared equals to 52 over root 3. Okay, then we calculated the area of the equilateral triangle DEF. We know that the area of the equilateral triangle DEF, according to the formula that I presented to you, equals to x times sine 60 over times sine 60 degrees over 2. So the area of triangle DEF equals to x squared times root 3 over 4. And we already know that x squared equals to 52 over root 3, so we can substitute x squared by 50 times over root 3 in this equality. And we found out that the area of the equilateral triangle DEF equals to 13 square units. The area of the equilateral triangle DEF equals to 13 square units. After we found out that the area of the equilateral triangle equals to 13 square units, we can calculate the area of quadrilateral DBEC, because the area of quadrilateral DBEC equals to the area of this triangle that is 8 square units plus the area of the equilateral triangle that is 14 square units plus the area of triangle EFC that is 15 square units. So in total, the area of triangle, the area of equilateral DBEC equals to 36 square units. The area of equilateral BDEC equals to 36 square units. But we also know that the area of equilateral DBEC or BDEC equals to 3 times the area of triangle AED. Okay? So from this equality we can derive that 3 times the area of triangle AED equals to 36. Okay? And if we divide this equality by 3, we will get that the area of triangle AED equals to 12 square units. So we found out that the area of triangle AED is 12 square units and the area of the equilateral triangle DEF equals to 13 square units. So the area of the green shape of quadrilateral ADEF equals to the area of triangle ADE, that is 12 square units, plus the area of equilateral triangle DEF, that is 13 square units. So in total the area of the green shape equals to the sum of the areas of the two triangles, that is 12 plus 13. That is to say, the area of the green shape equals to 25 square units. Again, the area of quadrilateral ADEF, the green shape, equals to 25 square units. Okay? Thank you very much.